Hello everyone, welcome to my channel. Today we are going to discuss about different types of data types. So data type, it specifies the type of data that a variable can store in the memory is called as data type. The type of data that a variable can store in the computer memory. So these data types are classified into three types according to ANSI. So that is primitive data type, derived data type and user defined data type. So here coming for primitive are called as basic data types supported by the C language. There are five types, that is integer, floating integer data type, floating data type, and character data type, double precision floating point data type, and the void. And derived data type. See here, primitive data types can store only one value in the computer memory. But using derived data types, that is, we are deriving the data type from the existing data. So using the primitive data types, we can obtain the data for different memory locations. For multiple locations at the same time, you can assign the data. So with the derived data types are nothing but they are structures, unions, arrays, and pointers. So they can these are the data types which can store multiple values in the location. But primitive data types can store only one value at a time in the computer memory location. And user defined data types. So these are nothing but from the existing data types itself, the user can design his own UDT. He can design his own abstract data type. So that is user data type. By combining the structures, within the structures he may combine the primitive data types. He may include some different types of attributes within the structure, or within the union, or within the array. So for complex data structures, whenever a program involves a complex data structures, at that time we can make use of user defined data types. So at this point we should know what actually is a data type. Data type is nothing but it tells us what type of data that the variable is holding. How can we say that what type of data that variable is holding? What is the syntax to be followed here? So for example, how to declare a variable declaration. These data types are used to declare the variables. For example, what is the syntax we follow to declare the variable? Data type space variable name. So in the previous video I explained how to declare a variable. Just go through that video. Data type, it can be any of the five primitive data types. For example, if I take int a, float, average. Okay, it means this keyword int is used to declare the integer data type, and keyword float is used to declare the floating data type. So int and float, they are the keywords. And what we have given, space data type space variable name. This variable names, it can be any number of variables. If you have more than one variable, we can write it as data type followed by variable 1 comma variable 2 comma and so on up to variable n. So how many number of variables you want, you can declare. So here I am declaring, this is the syntax to be followed. Int variable name, float average. So this is the variable name I have given, average a, like this. So a is of integer data type. It means that I am asking the compiler to reserve 2 bytes of memory for this variable. And average, it is floating data type. Floating by means it reserves 4 bytes of memory for this variable average. So like this we are giving instruction in our program to say that how much of memory has to be allocated for each of the variable. Okay guys, now just now we have seen how to declare a variable, that is using the data types. So now we'll discuss different forms of primitive data types. So coming for the first one, integer data type. Integer data type is represented with the keyword int. Okay, so int can be of two types. It can be signed int or it can be of unsigned, signed or unsigned. So here signed int means here unsigned int is used to represent only positive numbers. This unsigned int means it will represent only positive numbers starting from 0 to 65,535. Okay, that is we write it as 0 to 2 raised to n minus 1. And suppose if I am using signed int includes both positive and negative numbers. So the signed int will represent both positive and negative numbers. So the range, what numbers it will hold. So the range of the signed int varies from minus 32,768 to plus 32,767. The range. So any number which falls within this is nothing but it is considered to be as signed int if you are using signed int. Simply if I use int in my code means it's nothing but it's an unsigned int. So that is the meaning of that keyword. Okay, so anything between this range for signed int, positive, it includes both signed positive number and negative number. Unsigned includes only positive numbers. Its value, the number value varies from 0 to 65,535. Normally integer occupies 2 bytes. So coming for the next kind of data type, that is the character data type. Suppose my program is having a character data type. Character data type is represented with the keyword char. So here we use the keyword char to represent the character type of data type. So here when we want to represent a sequence of characters, then we call it as a string. Okay. Single character if you have, we may call it as a character data type, and if you have a sequence of characters then it is called as a string. They are always associated with variables to store a character or a string in a memory location. So always remember each character occupies 1 byte of memory. Each character occupies 1 byte of memory and its range is from minus 128 to plus 127. The range of numbers which falls under minus 128 to plus 127, we call it as character data type. So if you have unsigned char also it occupies 1 byte. We can use unsigned char. It occupies 1 byte of data and its range is from 0 to 255. 0 to 255. Simply if I use char, its range is from minus 128 to plus 127. If I use unsigned char, I have to consider only the positive numbers. So the positive numbers it includes from 0 to 255. Hope you have understood what actually it is now. The next kind of data type, primitive data type, is floating data type. So floating point data type. So now we are discussing the third method, floating point data type. And to represent the decimal numbers associated with fractions, we make use of this floating point data type. So we make use of the keyword float to represent the floating data type, and they are also called as what? Real numbers. This floating data types includes both positive and negative floating point numbers which can be stored in the memory. So they are represented using decimal point. How do we represent the floating numbers? They can be represented by using the decimal point and by using the scientific notation. In most of the systems, this floating point numbers has 6 decimal precisions. How much? After a decimal, how many digits it will support? That is 6 decimal precisions we say. Okay, that is after the decimal point. And float occupies 4 bytes of memory. So float, any variable which is declared as float means then we have to reserve 4 bytes of memory for that. And its range is from, it is from 3.4 e means exponent, minus 3.8 to, its range we represent like this, 3.4e plus 3.8. So like this we write the precision for the floating point. Any number which falls under this, it's considered to be as a floating number, which falls under this mantissa and exponent. It is considered as a floating number. Then the fourth type of data type is double. So this double is a keyword, double coming for double data type. It is a keyword used to define big floating point numbers. This is used to define big floating point numbers. So which is having higher precision, more than 6. So to represent higher precisions, we make use of this double floating point numbers. So both positive and negative big floating point numbers can be stored using this double data type. And the size and range varies from mission to mission. The size and the range of this double data type varies from mission to mission. Suppose it is a 16-bit mission. If it is a 16-bit processor means, if it is a 16-bit mission means, then the size is 8 bytes. Okay, for double it is 8 bytes. If you are using a 32-bit mission, if it is a 32-bit processor means, then its size will be 16 bytes. Okay guys, and the range also varies, and its range is, what numbers falls under this is 2.3e minus 308 to 1.7e plus 308. So the number, the precision and the mantissa should be within this range for big floating point numbers. So the keyword what we use is double. So for example, if I declare a variable like this, double sum. So the variable sum should be occupied. So the variable sum has to be allocated 8 bytes if it is a 16-bit mission, or 16 bytes of memory has to be allocated if it is a 32-bit mission. So that is the meaning of that. So this is how we declare the variable double. Then the last data type in the primitive is void data type. It is normally, this void is normally used in functions to indicate that the function does not return any value. The function does not return any value. Okay. So this void does not occupy any space in the memory, and the size of the void is 0. The size of the void is 0, and it has no range guys, and it has no range since it is in all types of mission. Okay, so void doesn't occupy any space. It's mainly used in the function to indicate that the function is not going to return any value. So this is about the declaration, this is about the 5 different kinds of data types, and we came to know how to declare a variable. For example, if I declare a variable as int count, float x comma y, char ch. See here, if I declare this, it means this variable count should be reserved 2 bytes of memory. In the memory, for the variable count, 2 bytes of memory should be reserved by the compiler. And we have here float x comma y. I am using the comma operator here and declaring two variables x and y. So x and y are a floating data type and each occupies how many bytes? Here float occupies 4 bytes of memory. So 4 bytes for x and 4 bytes for y should be reserved. So that is the meaning of this statement. Char ch. Ch is the variable and it is of character data type. So how much of memory should be reserved for this variable ch? 1 byte of memory should be reserved. Suppose if I have like this double g. So this variable g is of double precision floating point. So how many bytes of memory should be reserved for this variable g? 8 bytes of memory should be reserved. So that is the meaning of each data type. So how do we declare a variable? Data type followed by variable names. How do we assign a value to a variable now? Assigning a value to a variable. Variable initialization. We say that variable initialization and assignment. Suppose if I write int x equal to 10. It means that I am declaring variable x is of integer data type and this variable x is holding the value 10. So this variable x is initialized with, it has been assigned the value, it has been initialized with the value 10. So that is the meaning of this statement. Apart from that, how to assign a value, how to write an assignment statement. We write the assignment statement like this. Variable name is equal to some expression. So here variable name is nothing but name of the variable and expression, it is nothing but the value of the expression. For example, variable a is equal to b plus c. If I write an instruction like this, a is a variable, it is assigned an expression b plus c. Whatever the result b plus c we are going to get, that is assigned to this variable a. And in this case, you are initializing this variable x with 10. So somewhere 10 int 10 means what? 2 bytes of memory is reserved for this variable x. And x is equal to what now? It is 10. So 10 is stored in this memory location. 2 bytes of memory. So like that, we can assign a value to a variable. For example, if I write year is equal to year plus 1. So this is called as an assignment statement. Year is incremented by 1 and that result is assigned again to the variable year. So in this class we have discussed different types of data types and also we have seen how to declare and initialize a variable. Hope you understood. Please don't forget to subscribe, like, share and comment. Thank you.